Hello and welcome to this video where we're going to work on graphing a system of linear inequalities. So we have two inequalities and our goal is to find a shaded region where we can find points that work for both of these inequalities. So the way we do that is we're going to graph each one individually. Now when I see stuff written in standard form, I like to use what I call the intercept method, where I make an XY table, and I like it because it's pretty easy to work with because I'm letting X equal 0 and I'm letting Y equal 0. So that makes my arithmetic pretty simple. So for example, I take my inequality and I treat it like an equation. So I'm going to write it as an inequality, but in my mind, I'm looking at it as 2x plus y is equal to negative 6. Well, I put in 0 for x, that disappears. So I'm looking at that as an inequality, which is y is greater than or equal to negative 6. Y is greater than negative 6. So that just means y is negative 6. Now, let me erase that part, and this part right there. And now I do the same thing, but with the y variable. I put in 0 for y, and so that makes that essentially disappear. And I have 2x is greater than negative 6. Divide both sides by 2, and I'm going to get negative 3 there. Again, let me just erase this so that way I can reference it later. So what I can now do is plot the points at 0, negative 6 right there. Oh, there the eraser going. There we go. And negative 3, 0 there. I'm going to use my ruler to line it up so I can get a good straight line here. Like that. Perfect. And now my inequality is just greater than, so that means it's going to be dashed. So I will dash my line like that. All right. Cool. And we took care of one of them. Now let's take a look at the other one. Negative x plus 2y is greater than or equal to 4. Well, I'll use the same method, x and y, make a little table, 0 and 0. And now if I put in 0 for x, I have 2y essentially is equal to negative 4. Divide by 2, y is negative 2. Put in 0 for y, and x will have to be positive 4. So again, I have 2 points I can work with. So 0, negative 2 would be right there. And 4, 0 is right there. Use my ruler, line them up. Now the difference here this time is that, wait for it, there we go. I'm making a solid line because it's greater than or equal to. So solid line, boom. Now that I have the graphs drawn, what I can do is work on the shaded region. So I have to look at how each one of these inequalities is shaded. For the one in blue, or in order to do that, I like to test a point, again, that makes my life simple and easy. I like to test 0, 0. Oops, that's not here, right? 0, 0, 0, comma, 0. And the reason why I like to do that is because it makes everything disappear. The arithmetic is easy. Put in 0 for x, 0 for y, they both become 0. And so I have 0 greater than negative 6. Now, I'm asking myself, is this true or false? This is true. So I'm going to shade the side that had 0, 0, the side that was true. Now I'm not shading it yet because I want to see how it works with the other graph. So I'm going to go back to the other graph. I'm going to also test 0, 0 in there, and so that's going to give me 0 greater than or equal to negative 4. Again, this is a question. Is this true? It is true, so I'm going to shade the side that had 0, 0 on it, the true side. And now I can see where my graphs are going to overlap. They're going to overlap in this general area because I'm shading to the right of the blue line and above the red line. And so I'll shade here, and that is the answer to my problem. Any point in this shaded region works for either of these inequalities.